Hello everyone, my name is Rob Wicks and I have the rather unusual title of Lecturer in Space Risks here at UCL. So my job is half with the Institute for Risk and Disaster Reduction and half with the Mullard Space Science Lab. And we're looking at the interface between things that happen in space and risks. So the science application I'm going to talk to you about today is extraterrestrial hazard, aka space weather. So this is a fancy ESA artist's sketch of what space weather might be like, and we're going to go into this in a bit of detail, show you why space weather poses a hazard, what kind of hazard it poses, how we monitor it, how we forecast it, and then end with you guys designing a kind of space weather operational mission. So these are some sort of fancy pictures of what space weather can do. So the day-to-day impact that you might see or pay to go on holiday to see is the aurora. So something happens on the sun, which we'll come to in a minute. Solar wind comes out, hits the Earth, flows down the Earth's magnetic field and causes aurora around the North and South Pole. Now, that's the normal day-to-day process, which doesn't really cause us much trouble. But when this process becomes extreme, when we have extreme events in space weather, we can end up damaging our technological systems. So this nice, pretty glow in the sky is just like one of these light bulbs, right? It's glowing because there's an electrical current flowing. So if that electrical current is very, very large, it will induce a current in the ground. That current in the ground flows through our nice high voltage electricity system. In itself, that's not normally enough to damage it, but our grids are smart or not smart, depending on whether you're the engineer that built it or not, right? And the safety features in the grid will trip if that current is too large. When they trip, things go wrong, and this is a very expensive transformer from Canada that has clearly been destroyed through this process. So we're going to go through this process step by step in terms of science, then in terms of the impact it can have on the ground, and then what we're doing about it in the UK and in Europe in terms of forecasting. So space weather as a hazard. Space weather refers to the changes in the conditions in outer space. So the main driver is the sun, and the other main feature of interest is obviously the Earth, because that's where we live. The Earth has a magnetic field, and that magnetic field is a really important part of space weather too. It's only really of interest to us when it's extreme. Day-to-day space weather isn't too much of a problem. And we're becoming more and more exposed to it, especially in the Western world, because we rely on satellites. Satellites operate in space, so if the conditions in space change, it impacts satellites more than anything else. And also our reliance on advanced technology, electricity, GPS, other things like that are directly impacted by space weather. So space weather in the science community was a bit of a buzzword for a while. It's now being treated a lot more seriously. And that's partly down to a series of reports from insurance companies. So you can see here Lloyd's did a report into space weather in 2010. The UK government added extreme space weather to the National Risk Register in 2012. And that means the government, local councils and big businesses have a responsibility to consider space weather in their planning. Certain kinds of businesses anyway. And then in 2014, the Royal Academy of Engineering produced a report on vulnerability to space weather. In 2015, the UK government responded. BIS produced a report on what the UK government is going to do about space weather. And in 2016, the University of Cambridge Risk Institute published this thing called the Helios solar storm scenario, which basically lays out what the risk analysts at Cambridge think is the realistic worst case for an extreme space weather event and the impact it will have. So it's really in the last decade that this has moved into sort of the public consciousness, and it is being taken seriously. So what do we as scientists do, or where does this concept of space weather come from? It came from our observations of the sun. So space weather is caused when sunspots generate solar flares, and those solar flares may release big explosions of plasma from the sun. So plasma is superheated gas where the atoms have been split into electrons and ions, and it's what the sun is made of. So those big explosions are called coronal mass ejections. Flares, coronal mass ejections, and the solar wind come and hit the Earth. They squeeze the Earth's magnetic field. All of that combined together can cause several different effects, from radiation damaging satellites, these electrical currents flowing through the magnetosphere and then through the atmosphere that can induce currents on the ground and damage our electrical systems. So the only reason we don't care about space weather more than we do is that the Earth has a magnetic field. So the Earth's magnetic field is protecting us, and that's because the sun has a magnetic field, and that magnetic field comes out with the CME. And just like two magnets, trying to push two magnets together, the Earth and the solar wind repel one another. So most of the time, the solar wind is deflected around the Earth, and we don't really feel its full impact. We'll come on to that later in the lecture when we talk about the magnetosphere and how that's a double-edged sword sometimes. So basically, the rest of this 45 minutes or so, I'm going to discuss the sun and what happens on the sun to cause space weather, then the Earth and what happens at the Earth around space weather, and then finally the impacts and the forecasting that we do for space weather.